Okay, so here's the question. An example for Newton's laws of motion. A boy runs and then slides across a patch of ice on his knees. If the boy runs at a velocity of 3.2 meters per second forward and then slides 4.7 meters and finally comes to a stop, determine the amount of friction and the coefficient of friction of his pants on the ice. So what you need to do is draw a picture of what's going on in the question. So here's my ice. Here's the boy on his knees. Okay, he's sliding across the ice. So at first he is running at 3.2 meters per second. Okay, and then he slides a distance of 4.7 meters. And here he comes to a stop. Okay, so this is his initial velocity, right? So what do I know from the information and what do I need to find? So this is what I'm given. I'm given the displacement, the V1 and the V2, and I'm asked to find the force of friction and the coefficient of friction in this question. Okay. So the first thing I would do is draw a free body diagram. So if I draw a free body diagram, okay, so let's continue with our free body diagram. Now remember, on our free body diagram, we only put forces. So I'm only concerned about this point where the boy is sliding. So there is a normal force, there's a force of gravity, and those happen to be equal, and then there's the force of friction. And that's what's stopping the boy, and that's it. That's the only thing I know. So, in terms of Newton's laws, you need to think of what forces are acting on the object, what is causing the acceleration if there is any. In this case, there's definitely a slowing down, so there's going to be a negative acceleration that occurs over this displacement. And the only force causing that is the force of friction, because the normal force and the gravity are perpendicular, so they have no relevance to the friction directly. I mean, unless I have to find the normal force, but if you look here, I was not given the mass of the boy. So, what do I do? Well, I look to Newton's second law. Okay, Newton's second law says that F net equals ma. All right, and I forgot to give you the mass of the boy. So I have to give you the mass. I gave it in the last one. Let's say that the boy's mass is 55 kilograms. Okay? So if the boy's mass is 55 kilograms, okay, and I can find his acceleration, I'll know what the force of friction is. Okay, so the mass is 55 kilograms. How do I get the acceleration? Well, I look at the values I was given, and you have to go back and use motion. So in this case, I know V1, I know V2 and displacement. So it's going to be V2 squared equals V1 squared plus 2a delta d. And V2 is 0 because it comes to a stop. So if I want to solve for acceleration, I can rearrange this. Okay. And then divide both sides by 2 delta d. So I get that acceleration equals negative v1 squared all over 2 delta d. Now, you can solve for acceleration and get a number, but I'm going to choose to write this in here. So my v1 is negative 3.2 meters per second. It's this quantity that's squared, not the negative, okay? It's just the velocity. And that is to the right or forward, all over 2 times delta d, 4.7 meters. Let's put that in our calculator, 55 times 3.2 squared divided by 2 times 4.7. Okay, and I get 59.914, and this is going to be negative. Negative to the right. Also, I should probably take a look at my units. So I didn't bother putting the negative in my calculator. I don't know if you noticed that, because I know that that will still be there. So I have a kilogram, then I have a meters squared per second squared, but I also have a 1 over meters here as well. So one of those gets divided away, and this is my units to the right, which is a kilogram meter per second squared, which is a Newton. Now, significant figures, I have 2, 3 here, so in the end I can only have 2, so it's approximately, and I happen to have 60 newtons to the right. Okay, and there's the force of friction. Now, what is mu in this case? All right. Well, the force of friction is equal to mu mu Fn, but in this case, Fn and mg are the same because it's on a horizontal surface. So I'm going to rearrange this for mu. Mu is the force of friction all over the normal force. The force of friction is the 59.914 newtons, and Fn is going to be mg. So this is the 55 kilograms, okay, times .8 meters per second squared, okay, and then that's going to cancel out with the units. You notice I didn't put any directions here because mu is just a scalar and it's just a number. There are no units with it. So 59.914 divided by, and I'm going to use a bracket, 55 times 9.8, close the bracket, I get 0.1111. It's just a number. So let's get my final answer here. The force of friction is approximately equal to 60 newtons to the, I put right here, this is negative, right? So let's change this to the left, and mu is approximately equal to 0.11. So the boy experienced 60 Newton force of friction because the coefficient of friction is 0.11 between his pants. So let's just go over what I did. Okay, I was given the question. From this information, okay, that would give me the acceleration. When I draw the free body diagram, that leads me to using the second law. The only force in this case is the force of friction. So F net is equal to the force of friction. And then I solve for the acceleration. So I could find the force of friction and then use the relationship for friction and the normal force to determine the coefficient of friction. Okay, thanks. Bye.